Good morning, everyone. Good morning. All right, I think that should take care of everybody. Did I get a good morning from anyone?
Good morning.
Thank you.
Morning.
Thank you. Give me a little bit of love.
I'm so excited for today's class.
Yay.
I just love math. Let's go.
You don't have to guess it too much, okay? All right. All right, any questions, comments before we get started today?
Wait, so what's the plan for today? Are we just going through things, or do we got like a quiz?
The plan for today is to review for your test, which is going to be tomorrow on Brightspace.
Thank you.
Okay.
Did the Ed puzzle lessons prepare us for like if you did
everything
them well?
You've been doing this week on Ed puzzles, the little videos, the little practice quizzes, all of those are the topics that will be on the test tomorrow. Okay, so all of those things should have been things to prepare you for the big test tomorrow. It's the unit test tomorrow. You had the two bigger quizzes, you had practice quizzes, and now you're going to have the big unit test. Okay, so I hope it was a little bit different this time than we did with sets. I was hoping that the little extra videos kind of gave you a little more interactive review, and the practice quizzes, you asked for more quicker feedback, and that way the practice quizzes allowed you to get feedback quicker to know whether you were doing the problems correctly or not. Some questions during the quizzes, during the videos also let you know whether you were taking in the information correctly or not. So that way you could go back and relook at the videos if you had trouble. So I hope that was a little bit better in terms of trying to review and get the information from the concepts rather than just study the notes and do problems. It was a little bit different approach. I hope you found that a little bit better. It's not great, but it kind of helps when you don't have a person to interact with. It kind of helps that way to help you get through the information. So I hope you found it a little bit better. Any other questions about that?
You said that test is when?
Tomorrow.
Okay.
Okay. It will be posted tomorrow and due by the end of the day tomorrow. Okay. This afternoon, I'll be posting a review sheet to go along with what we go back over today. I'm just going to kind of go over everything together today one more time. So you hear it one more time, it refreshes you one more time, a few more examples to kind of put it all back together. As I go back over the review, you need to be sure you stop me if there's an area that you're having trouble with, you need more examples on, or you don't understand that particular part of it. And as we go through it, that's what the review's for. It's for you. It's not for me. I obviously know what to do, but as we go through it, I'm just trying to point out different things. This is what you need to know. This is how you do it. If that's an area you need help with, you say, hey, I need more problems there. I need more help there. Okay? Any questions there? All right, so that's the plan for today. After the test tomorrow, over the weekend, I will be posting a PowerPoint with some notes about functions, our next unit, just to kind of give you a heads up and a lead in to what we're going to be working on next week. You won't have a great deal of work over the weekend, but it will just kind of give you a heads up view into what we're going to do. I know there's lots of activities going on over the weekend. You don't want a lot of work. So we'll do the test tomorrow, get it out of the way, and then y'all can focus on your weekend activities. Okay? That sound good? All right, so that's our plan. Anybody else with questions there?
Those practice quizzes are due today, right?
Yeah, they are. Okay, there are 2 practice quizzes. This last lesson had more videos than the first lesson, but the videos are part of the participation grade. So all of it combines together for that participation grade. And just working through all of it. Okay? All right, the practice quiz, the 2 quizzes that you did on Brightspace, there are also attendance grades for Monday and Wednesday. So you want to be sure that you take those in too. So just so you understand what's going on. All right, I'm going to switch to the notes screen. Can everybody see the blank paper? Anybody not see that? Just a reminder about your videos being on. I like to put faces with names, and without your videos, when I can't see you, it is hard to put faces and names. I go back and look at the videos and of class times, and I see whether you've been active in your videos. That means face showing or not. So working on the probability review. We want to start at the beginning. What is probability? It is the chance of something happening. The way that we calculate probability is to use that notation, capital P. We use the name of the event equals the number of ways it can happen over the total number of ways. That's the number one thing you need to know about probability. Probability is the chance of something happening, and how you calculate it is by finding the number of ways it can happen compared to the number of ways that it's possible to happen. We do express probability as a fraction, as a decimal, or a percent. It can be any of those three forms when we write a probability. The most common way is a fraction, and whenever we use a fraction, we always reduce it, always in simplest form. As you're picking out answers for a test or a quiz, if you didn't select the simplest form, it would not be correct if you didn't select the simplest form. The first part of understanding probability is to understand the concept, and we look at that by looking at the probability number line. So probability is a value that goes from 0 to 1 on that number line. It doesn't go beyond that. The lowest value probability can be is 0. The highest value probability can be is 1. So if you have a probability of 0, that means that the event is impossible. It will not happen. If you have a probability of 1, that means the event is certain to happen. Like today, it's certain to rain. It's going to rain today. It's 100% chance of rain. The probability is 1. It's going to rain today. If it is halfway between those two values, that means the probability value is 1/2. When we talk about the amount of that probability, it is evenly likely to happen. It's just as likely to happen as it is just as likely to not happen. So if it's halfway, you can't predict one way or the other that an event is going to happen. It is equally possible. But then if an event has a probability that is higher than 1/2, so it's between 1/2 and 1, that event that falls in that range is more likely to happen. An event that has a probability that falls between 0 and 1/2, like 1 out of 3 chance, that event is considered less likely to happen. So our first picture of probability is not only to look at how it's calculated, but to think about what does that chance mean? How do we look at that number that we get? What does that number mean? It means what is the likelihood that that probability is going to actually happen. So we want to be able to interpret the answer that we get. So what is probability? How do we interpret the answers that we get? That is a conceptual concept that we need to know about probability. Then we get into talking about the types of probability, and we talk about empirical probability versus theoretical probability. Empirical probability is also known as experimental. I'm sure in some of the little short videos that you've been watching, you've heard that term come across. When you're dealing with empirical probability, that means that you're going to use the actual values in an experiment. So, for example, if we had an experiment where we were tossing a coin and we were wanting to find out the number of heads that occurred, then we would toss the coin 100 times. If it landed on heads 65 times, we could determine the probability by using that data. It was heads 65 out of 100 times. If we express that as a fraction, then we always reduce that. So that would be 13 out of 20 times. If we express that as a decimal, 65 divided by 100 would be 0.65. If we express that as a percent, we change a decimal to a percent by multiplying it by 100. So that would be 65%. So that's just a quick little review on how to change from one form to the other. But the concept here is using the experimental data to actually calculate the probability. Well, what's the difference between empirical versus theoretical? Theoretical says that we use a general rule. We don't have to do an experiment. Excuse me. So in the accepted rule or the accepted theory about tossing a coin is that it's going to land on heads 50% of the time. That is not the same answer that we got from that empirical probability. Why is that? Why are they not the same answer? And that's where that theory, law of large numbers, comes into play. The use of large numbers. The more experiments or the more trials in your experiments, the closer empirical probability becomes to theoretical. In other words, if I took this same experiment, tossing the coin, and repeated it 10,000 times, the number of heads that I obtained would be a percentage that was closer to the 50%. I may even have to repeat that experiment 100,000 times in order to reach the 50%. But it is the theory of large numbers. The more times that I repeat that experiment, the closer I will get to that theoretical probability. And that's where that accepted rule came from. The fact that someone many years ago did that experiment enough times to come up with that rule of 50%. That everybody says, okay, that's what's going to happen, no matter what, 50%. The only time that doesn't happen is if you had a weighted coin that would make it land on one side versus the other. And those do exist out there. We have to be careful about that. Now, some other vocabulary that we need to be familiar with is the term experiment. We used that just a few minutes ago. Experiment means a repeated procedure that yields a result. Our experiment was tossing the coin. The term outcome is what are the possible results. In this experiment, the possible results was either a head or a tail. The event is one or more outcomes. So when we tossed it the first time, we got a heads. We tossed it the second time, we got a tails. Those are the events that are occurring. The sample space is all the possible outcomes. In other words, we tossed it 100 times. We got the 65 heads. Well, how many tails did we get? Well, we got 35 then. 100 minus 65 would be the 35 tails. So the sample space needs to include all of that information. So not only with probability do we need to know the difference between empirical versus theoretical. Theoretical is the type that we use most often, but we need to know the vocabulary that's used with probability quite often. Any questions so far? I think we should be good with that part of probability. That's pretty much ingrained in us with what we've done so far, right? All right, the next step in probability is looking at sample space. So sample space is finding what all those outcomes are. So with sample space, we looked at some techniques to help us find sample space. There are lots of them out there. We looked at a few of them. We said we could make a list. We said we could use the fundamental counting principle. We could make a table. We could use a tree diagram. We could use permutations. Or we could use combinations. We could just lots of ways. We could just try something, see if it worked. Trial and error. Lots of ways to find sample space. The most common method to find out how many is to use the fundamental counting principle, use permutations, or combinations. All three of those will tell us how many outcomes. Now, a tree diagram and a table all will also tell us how many outcomes there are. But if we want to know what the outcomes are, what specifically they are, then we want to use the tree diagram, the table, or make a list. We have to use something other than the counting principle, permutations, and combinations. So depending on which that we need to know, do we just need to know how many, or do we need to know what they are, will make a difference in what technique that we use to find the sample space. So let's look at a particular problem. So we have a small ski resort. They have 3 types of skis. They have a standard type. They have a deluxe type. And they have a professional model of skis. They have 2 types of boots to wear. Either an economy boot or the high grade. That question, what are the number of outcomes, might also be worded as how many possible ways to rent equipment. So those two questions are asking for the same thing. It is a little different, but they are asking for the same thing. That question is asking us just to find out how many. So the quickest way to find how many is to use the fundamental counting principle to do that. In order to do that, we just multiply how many types of skis, 3, times the number of types of boots, which is 2, which gives us 6. So there are 6 ways to rent the equipment. So that question was really easy to answer. We just use the fundamental counting principle to do that. Now the next question makes it a little more difficult. What are the prices for each combination? That means that we need to know what are the outcomes. Now, since we need to know what the outcomes are, we need to either use a tree diagram or a table in order to figure out what the combinations may be. So let's start with a tree diagram. When there's not a lot of choices, a tree diagram is usually your best bet. It's quick, easy to use. If you have a lot of choices, a table might be your next best choice. But sometimes it's just a personal preference. What is it that you like to do? What do you understand the most? So if we were doing the tree diagram, we would start maybe with the skis. So we would have the standard skis. We would have the deluxe skis, and we would have the professional skis. And then we would match up the boots with them. So each of those skis would have 2 branches where we would have the economy boot or the high grade boot. And that's what our tree diagram would look like. Now, if you prefer to do your tree diagrams horizontally, this is a vertical one. You can do that. So you could have done, as well as you could have done your boots first, branch to your skis. So I did skis to boots. But if I wanted to do boots first, and I did economy to high, and then branch to skis, I would have 3 branches from each of my boots: standard, deluxe, professional, standard, deluxe, professional. So I can do it vertically, I can do it horizontally, I can put skis first, I can put boots first. That doesn't matter. You can do that tree diagram in any of those forms that you would prefer. If I was doing this in a table, It's just a matter of arranging the data in rows and columns. What you put on rows and what you put on columns are certainly up to you. So if I have standard, deluxe, professional for my skis in the columns, and then in the boots, I put on the rows, economy and high grade, and then I don't need this row. I match them up, economy with standard, economy with deluxe, economy with professional, high grade with standard, high grade with deluxe, high grade with professional. What are my outcomes? Again, I know I should have 6 because that's how many I found out I should have. Whether I do the trees or I do the table, the branches, E to S or S to E, whichever way you want to read that, S to H, or H to S, that's the same thing. The order there doesn't matter. D to E or E to D, D to H or H to D, P to E or E to P, and professional to high grade, or high grade to professional gives me my 6 outcomes. If I did it from the horizontal, E to S, E to D, E to professional. Helps if I write that so you can read it better. But using your tree diagrams or your tables, vertical versus horizontal, you still come up with what your outcomes are. The major focus of doing this is being able to read the tree diagram and coming up with the outcomes, or reading the table to come up with the outcomes. And a lot of times when you're dealing with problems, you're needing to be able to use the diagram to figure out what the probabilities would be. So that's kind of how they're given to you in terms of problems. You need to be able to follow the tree diagrams to come up with what the probabilities are. A lot of times the probabilities are given on the branches. What's the probability of this happening? It's 1 out of 3. And then there were 2 choices, so that's 1 out of 2. And you multiply the 2 together to get the final result for the probability. So that's how you deal with finding the probabilities for them. Okay, so that's tree diagrams and finding outcomes with those. The next step is to look at finding outcomes using permutations and combinations. So let's look at an example there. Let's first review what are permutations and what are combinations. So a permutation is the order of arrangements where the order will matter. The notation that's used is P of NR, or N capital P little r, and the formula is N factorial over N minus R factorial. And just as a side note, we had looked at what a factorial was. That's that little symbol with the exclamation mark. So 4 factorial means 4 times 3 times 2 times 1. And you calculate that to get 24. Whether you have a TI-84 or a TI-30 calculator, you should find that symbol on the calculator and it will do that calculation for you. But if you don't find that key on there, that is how you would calculate that particular problem. A combination is the arrangement of items when the order does not matter. That notation is C, N, R, very similar to permutation, or N, capital C, R, but the formula is a little different. N factorial over R factorial, N minus R factorial. So how you calculate it is a little bit different. If I wanted to do a sample problem for permutations, 5 items, selected 3 ways, that would be written 5 permutation 3. Just to review on your calculator, remember that you would type in the first number first, that large number, 5. You would press the math key, go over to prob, down to choice P for the permutation, and then type the second number 3 to get your result, which comes out to be 60. If you have a TI-30 calculator, it also has that NPR key on there. I don't remember the exact steps to get to it, but there is a menu that allows you to get to that NPR key so that you can do that calculation automatically on that calculator. I don't have one to show you how to press exactly what keys to show you, but it is available on that particular calculator. If we were doing this problem on combination, we might have 8 items, selected 5 ways. So that would be written as 8 combination 5. So on our calculator, we would type the 8 first, press the math key, go over to prob and select the third choice there for combination, and then press the second number 5 and enter, and we get 56 for that result. In preparation for the test, you do want a calculator. If you don't have one, I encourage you to either buy the TI-30, which is about 20 bucks, or to borrow one. I would not encourage you to buy a TI-84 if you don't already have one, just because of the expense. You will be using some of the graphing part with the functions, but it's not mandatory to have that. It just will be an assistance. But I wouldn't put the money out for this calculator unless you're aiming to take more math classes. The TI-30 should be sufficient for what you're going to do, for what we're going to do for class. But it would be beneficial for the test to be sure you have a calculator. But if you haven't practiced on the calculator, you're going to fumble a little bit with how to do these calculations if you haven't practiced with that calculator. So it is important that you know how to operate the calculator as well. All right, now let's look at some particular examples using permutations and combinations. Here is a particular problem. We have a birthday party. Anne's having this party and she is very particular about her music. She has 8 musicians that she is finds as her favorite. That she wants to play at the party. But she has some stipulations that's pretty unusual. She wants the, instead of shuffling all the music to play randomly, she wants one artist to be played at a time. And she wants all their songs played. Whenever they do play. So the question is, how many ways to arrange the artist? One way to think of this problem is to think about that we have the 8 positions. When we play that first position, we have 8 musicians to choose from. After we play the first musician, we now only have 7 musicians to choose from. And then after we play the first 2, we now only have 6 musicians to choose from. So this problem continues in that same pattern. And we end up with 8 factorial. Because the order mattered in terms of who we selected first, is this problem a permutation or combination? Did the order matter? Yes. Once we selected one, we couldn't select it anymore. So the order did matter. So it made it a permutation problem. So if we were going to calculate this problem by permutation, we would do this by 8 permutation 8. We selected all 8 of the artists. When we calculate it this way, 8 factorial, we get 40,320 ways to arrange them. When we calculate it this way, we should get exactly the same answer. So this is a problem that could be done either way. If I had a problem where I had a class of 20 students, and I wanted to select 5 students to attend a conference. How many combinations would that make? Now, I'm giving you a clue there, of course, by saying combinations, but I could say how many arrangements could that be? This is a combination problem, so it would be 20 combination 5 ways, which is 15,504 ways. The wording sometimes is not quite that obvious in a problem. So permutation versus combination. All right, this is a good stopping point to take a break before we continue with the rest of the review. So let's take a break for about 10 minutes. So we should be back at about 11:45 after your break. So if you have any questions or anything comes up during break, please let me know. All right. All right, see you back in about 10 minutes.